From the campus of St. Louis University in St. Louis, Missouri, HEC TV proudly presents St. Louis University's 7th Annual Safety Across High Consequence Industries Conference, where safety meets business.
Thank you. I would like now, if I can, to introduce our first speaker, the scheduled agenda today, and that's Damon Larsell. Damon is currently the program director for CASER, the Center for Aviation Safety Research. Damon has significant experience in commercial and corporate aviation and maintains research interests in the area of safety management systems and next generation aviation maintenance. Damon has extensive experience working with the FAA on safety management system initiatives and has worked with aviation service providers developing and implementing SMS into their organizations. He's held various leadership positions with Midcoast Aviation and Saberliner Corporation, with experience managing a breadth of disciplines to include maintenance, modifications, repairs, certification, and engineering. He's currently completing his PhD in aviation from St. Louis University and holds a master's in business administration from the University of Missouri and a bachelor's of science in aviation operations from San Jose State University. And he's going to be talking about the basic principles of safety management. Thank you.
So what I'm going to talk about here, first of all, is just an overview, background of SMS, safety, and how we got where we are today. So since my background is in aviation, my perspective is going to be from aviation. And the theory of safety management has its beginnings in risk management. And risk management is simply deciding what is a hazard and can I live with it or not. And the idea of risk management has been around for over a century. And back in 1901, the Wright brothers were performing a rudimentary type of risk management. And for them, it was truly life or death. Safety management has its roots in behavior-based safety, which grew out of the work of a gentleman by the name of Herbert Heinrich. Heinrich worked for Travelers Insurance back in the 1930s. And what do insurance companies do a really good job of? They manage risk. Heinrich analyzed over 75,000 industrial accidents. And from this, he developed a model referred to as Heinrich's pyramid. So here we see Heinrich's pyramid. And what Heinrich found out was that there was a mathematical relationship between unsafe conditions and incidences and accidents. In short, what he found out was that for every accident a company incurs, there were relatively 1,000 unsafe acts. More importantly, these acts and conditions are leading indicators to how many accidents or incidences an organization will have. Thus, you can see how this relationship was of value to an insurance company. By reducing the number of unsafe acts and hazards, the lower the likelihood of an incident or accident. Heinrich's research concluded that 88% of accidents are attributable to human error. Behavior-based safety programs were the first safety programs focused on the acts that caused the accident and not the actual outcome or the accident itself. Behavior-based systems focused on the predictive and not just the reactive. So looking at some of the historical events, or I would say not so popular events regarding safety, safety management concept grew out of an aftermath of several disasters. First, the Flixborough disaster in England in 1974. Chemical plant exploded there, killed 28 people, and destroyed the town. The reason for the failure was an improperly installed pressure line. Worst of all, the company knew the line was installed improperly. Employees walked by it every day and knew it was installed improperly. Next, the Seveso disaster in Italy in 1976. This event was the largest accidental release of dioxin gas to date in the world. Worst of all, the company did not even know what happened for almost a week. 88,000 farm animals had to be slaughtered due to contamination, and the people in that town are still feeling the health effects today. The cause? Improper procedures and a poor system design. And I think we're all familiar with this event, Chernobyl, 1986. One of the contributing factors was a poor safety culture in the organization. The Herald of Free Enterprise in Belgium, 1987. Passenger car ferry capsized, killed 193 people. The ferry left the dock with the cargo doors wide open. And as the ship was moving through the water, the waves crashed over the bow, filled the ship with water, and it capsized. Investigators cited major errors on the part of management and a culture of sloppiness. Next, we look at the Piper Alpha oil rig explosion in the North Sea. This is the most deadliest oil rig accident to date. 167 people killed, and investigators cited poor safety management on the part of the organization. So now, if you're thinking that, hey, all these events happened overseas with our other colleagues, in the United States, we're good to go. We don't have to worry anything. Well, to illustrate that the United States is just as capable of tragedy and destruction, I have these examples. Space Shuttle Challenger disaster. Investigators found severe failures in organizational communication, which led to poor decision making. Dozens of people knew about the faulty O-rings, which caused fuel to leak and eventually led to the explosion. But this information was ignored or not communicated to the people who needed to know. Next, we look at the Continental Express flight 2574 in 1991. This airplane, the night before, was having maintenance conducted on the horizontal leading edge, up here, this area. They were changing out the de-ice boots. Well, overnight, shift change, several events took place, resulted in the mechanics forgetting to install all of the fasteners on the leading edge. The next day, while the airplane was on descent to land, the leading edge ripped away and caused the aircraft to immediately enter into a nose-down dive, killing all aboard. The NTSB cited one of the probable causes as a failure in the corporate culture regarding safety. And all too familiar to all of us is the BP Deepwater Horizon oil disaster in the Gulf a couple years ago. Findings included that safety management had significant deficiencies and a culture of complacency. Maybe a lot of you don't know this, but the BP Deepwater Horizon, just shortly before this occurred, had won a safety award for being an example of how to conduct work. So in this picture, this illustrates kind of our walk, our evolution of safety. Initially, our technology wasn't the greatest. It was unreliable, required a lot of maintenance, was difficult to use. So we looked at technology to help us improve safety. In aviation, the example I cite is that a few years ago, controlled flight into terrain was common. And what I mean by that is where a pilot, co-pilot, they fly a perfectly good airplane operating absolutely 100% into the ground. So through technology, they developed what they call is an enhanced ground prox warning system, which helps alert pilots, when the aircraft is not configured right, or when the airplane is is headed towards a mountain or rising terrain, or is sinking too fast. And with that advent of that technology, controlled flight in terrain, those incidences have basically been eliminated. Next, the focus was on the human being. Yes, we can be the source of our own problems. The focus was on training, human factors, ergonomics, that type of human technology interface. Today, the focus is on the organization. All of the examples I cited earlier were demonstrations of how the organization was attributable to disaster. And this is the focus of safety management. It's on the organization. SMS is all about decision making. It's about improving decision making. SMS is not your typical safety program. It's more than OSHA compliance, painting some yellow lines on the floor, labeling chemicals, or following maintenance manual procedures. SMS is a company actively managing safety as it would other vital business processes, such as accounting or operations. Safety is a factor in all decision making. So historically, safety has been managed in a reactive manner. What do I mean by that? We kill somebody, we blow something up, we tear up some equipment, then we investigate how it happened, come up with a fix, and then we carry on our merry way. However, this is quite a costly way to manage safety. The purpose of safety management is to move the organization to a proactive and predictive model of managing safety. Moving from a mindset of, hey, we're doing well, that's great, to, hey, we're doing well, what are we missing? What hazards lie in wait that we don't know about? How can we improve? So looking back at Heinrich's pyramid, we see the focus of SMS. SMS is not just looking at incidences and accidents and reacting to them. SMS goes beyond by trying to identify the conditions and the acts that led to the accident. That's important, looking at the acts, the incidences, not the actual outcome. The bottom of the pyramid, right here, unreported unsafe acts, hazardous conditions, that's the hard part. But that's where the gold is. That's where the data is that you need to know about. And the only way you're going to get to know about that data is having your employees tell you about it and feel they can tell you about it and want to tell you about it. Because if you don't know about this stuff, you can't do a whole lot about preventing that. So, benefits of SMS. SMS provides benefits beyond just safety. SMS concepts are based upon fundamental and innovative business practices. SMS helps to minimize repeated mistakes. It empowers employees to look for better, faster ways to do things, safer ways to do things. and improves the organization ability to learn and the speed by which the organization learns. It provides a competitive advantage, and most importantly, again, it facilitates better decision making, not only for safety, but a broad array of business decisions. These benefits ultimately equate to a better bottom line. So now I'm going to shift away from the kind of the background and the purpose of SMS and talk about the components of SMS from an FAA perspective. This is somewhat their model. And there are 4 components to SMS, or what are commonly referred to as pillars. These are safety policy, which is mainly focused on safety leadership, ethical decision making, and the associated documentation of the SMS. Safety promotion, largely associated with the organizational culture. And then we have safety risk management and safety assurance, which I'll touch on a little bit more in detail here in a minute. So the safety policy and safety promotion, those are what are commonly referred to as the administrative elements of a safety management system. Safety risk management and safety assurance are what are referred to as the operational components of a safety management system. So later in the conference tomorrow, we'll have a lot of discussions that center around safety policy and safety promotion. So I'm just going to briefly go over those, but there'll be more discussion on those tomorrow. So safety promotion, quite simply, it's the glue that bonds all SMS activities together. Safety promotion consists of creating a strong safety culture in the organization with an air of openness. Safety promotion encourages and facilitates communication both up and down the organizational structure. Safety promotion provides a mechanism for employees to report safety information, or what is commonly referred to as push information to the organization. Safety promotion also actively seeks to pull information through auditing, monitoring safety performance, and employee surveys or interviews. Everyone in the organization plays a part in promoting safety. Safety policy. This is the company committing to developing, implementing, and maintaining a robust safety management system. It's a commitment to safety leadership and acting legally and ethically. The safety policy also documents the processes and activities. Simply put, safety policy is the company putting on paper their commitment to safety, commitment to a safety management system for the whole world to see. Now getting into the operational components, safety risk management. SRM includes the documented safety-related processes and procedures of the company. SRM is focused on identifying hazards, assessing the risks of these hazards, and putting into place the necessary risk controls. This is an area that many organizations perceive as daunting and labor-intensive when it comes to implementing an SMS. Many organizations already do risk management to some level. If you have a good operation, you're doing this to some extent. However, it's probably not documented or formalized into a true sustainable process. Implementing SMS does not require a complete risk assessment of your current organization. And what I mean by that is a lot of organizations that we've dealt with when it comes to implementing SMS think that I have to identify all of my hazards. I have to assess the risk for all of those hazards. And then I have to put in place the necessary risk controls for all of those hazards. Well, if you look at it that way, it is very daunting if that's where you want to start. But the focus needs to be on getting the system implemented, documented, get it up and running. And then let the employees, let the system give you the data, give you the information, and then act upon it accordingly. Safety assurance is similar in many ways to quality assurance. The differences are in regards to hazard identification and the information gathering component. Safety assurance assesses the safety performance of the operation, including any hazards. Information gathering, again, is a key component of safety assurance. Hazard identification. What is a hazard? I think each one of us in here might have a different definition of what is a hazard. Somebody might perceive that light as being a hazard. It could fall. Others might think, that's not a hazard. So we all have a different perception or opinion on what is a hazard. So perhaps a better way to answer this question is to look at why hazards exist and where to look for hazards. Hazards exist because of two primary factors. First, the hazards just naturally exist in the system. For example, aviation. If I own and operate an airline, weather is a hazard. No matter how hard I try, I can't eliminate that hazard. It's something that I have to deal with. Same thing in healthcare. Germs are a hazard. No matter how hard I try, I cannot eliminate all of the germs in my hospital. Second, our operation may not have adequate safety controls built into the system, or our system inherently introduces hazards. The key is getting the information to know what the hazards are and the associated risks, and making decisions based on this information. Basic principles of hazard mishap theory. A hazard is a condition that defines a possible future event. However, a hazard alone is no guarantee that something bad is going to happen. A hazard and a mishap are two different states of the same phenomenon. So for example, the brakes on my car are faulty, so my car won't stop. But if I make a decision to get in my car and drive, and because my brakes are faulty, my car doesn't stop, I have an accident. Each hazard has two attributes, probability and severity, and I'll touch on that more in a minute. So here we have this hazard triangle, and all three of these are needed to go from a hazard to an incident or an accident. I need some hazardous element, I need a target or threat, and I need some initiating event. So this chart is kind of we're going to run through a couple of these examples. So let's look at the second one, traffic. My esteemed leader, which many of you know personally, was nice enough to send me to India for 7 weeks last year, 2 different occasions. And I'm from Southern California, lived in the LA area for a number of years. And let me tell you, in LA, the traffic can be horrendous. I've been to New York City, New Jersey area, vacation on business. Traffic there can be really bad. However, I think if you took Los Angeles and New York and combined them together, they wouldn't even come close to the traffic in Mumbai, India. So, in Mumbai, India, there were on occasions where I had to decide, did I want to cross the street? So the hazard was the traffic. The initiating event was me crossing the street. The target was me, the pedestrian. The mishap or the risk was I could get hurt, worst case, or be killed. Mitigation, I'll use the crosswalk. But guess what? In Mumbai, India, they do not have crosswalks. So more often than not, I elected not to cross the street. Another example from aviation, screws. So I'm a mechanic, I'm walking across the hangar floor, and some screws fall out of my toolbox. The target is the aircraft tire. The mishap or risk, well, if the tire is punctured, somebody could be injured, or some equipment could be damaged. So the mitigation, maybe I implement some different storage containers, and I do what we commonly refer to as FOD walks, foreign object damage, debris, where I have people walk through the hangar on occasion on regularly scheduled intervals looking for debris on the hangar floor and picking it up. Risk assessment. What is risk? Again, we probably all have a different perception of what risk is. The concern is not so much about defining risk, but assessing the level of risk of a given hazard. The level of risk, quite simply, comes down to this mathematical equation. The probability of an event occurring multiplied by the severity of the event. The next question that needs to be answered is the level of risk acceptable? There are direct costs. There are indirect costs. If something happens, what's the impact to the reputation of my company? And the indirect costs are very difficult to put a number on, and sometimes they can be the most costly. Hazard identification. Where should we look? The key here is change. Whenever something changes in my organization or your organization, you should be wary of what hazards have just been developed. New hazards. Many hazards can be found with new technology, using new aircraft in your airline, using new instruments in the operating room, even changing location or opening a location in a foreign country, changes in employees, changes in ships. The key is anytime you see a change, there are probably new hazards that have just been developed. So looking at this chart provides a tool or outlines the thought process about how you would go about assessing risk, assessing the level of risk. So over here, I have risk likelihood, and across the top is the severity. So red is high risk level, high severity, high probability. So if it's in the red, you know what? That's pretty high risk. I need to do something about that. I need to put in some risk controls, or I might even decide I'm not going to do this activity at all because I just can't get the risk. Even with putting risk controls, I can't get it out of the red and drive it more down here to this bottom corner. So for instance, if I'm an airline and maybe I'm going to fly into China, I've decided, you know what, I want to look at opening a route into China, maybe up in the mountainous area. So I'm looking at a particular town that has an altitude, has a high altitude runway. It's not exactly the longest, and there's a lot of granite sticking up in the clouds around it. I might look at that and determine, you know what, I could make money off of it, but the risk is just too great, no matter what I do. Here's a simplified picture of what this process might look like. And over here under risk perception, this is better titled hazard identification. So in this picture, I identify a hazard, the rock above me. I do a risk assessment. What's the likelihood of that rock falling? Well, it looks like it's pretty good. What's the severity? Well, if it falls with me standing here, I could probably get killed. So how do I manage the risk? I get the hell out of the way. Okay, this one is going to require some attention. But basically what we're going to do here is illustrate the operational components of SRM and safety assurance and how they interrelate with each other. So there's 5 areas that are common to both safety risk management and safety assurance. We have the description and operation, the data collection, I'm getting my information, the analysis, what is the data telling me, making a decision based on the data, and then taking some action. So over here we have SRM, and over here is SA, and we'll start with SA. So I have my system operation. It's up and running. I'm making widgets, whatever. And I'm collecting data. I'm measuring my safety performance. I'm measuring the outcomes. Is it what I want? That's where the analysis comes in. I look at the data. Does it make sense? Do I feel good about what's going on? Then I make a decision. Good or bad? Is my system doing what I want it to do? If it's good, I don't do anything. I let the system operate. If I have some corrective action, if the system design is okay, but maybe within the system, you know, I have some employees that need some more training, or I have some equipment that maybe is not operating up to snuff, needs some repair, the safety guards are broken, whatever, then I fix those. So I take corrective action to fix that, and I keep the system running. But my system is good. If I decide at this point that, hey, you know what, my system is not so good, I need to look at changing it, then I move it over here to the SRM process. And I look at my system and identify my hazards. You know, I get my hazard information from over here, which includes audits and employee reports. Then I analyze the information. What's the data telling me? Am I happy with the risk? Do I want to, is it acceptable? Yes or no? If it's no, then I need to do something about it. I need to put some risk controls in place. So I put in place some risk controls. Okay, so the key here is I'm making a change to my system. What do we say about change? Great opportunity for hazards. So I just don't stop there. I make the change to the system, and I put it back through this process to analyze it, because my change might have caused other hazards in other areas that I might not have been aware of. So I look at the hazards, I do my risk analysis of my new system, risk assessment, is it acceptable, yes or no? Yeah, I'm good with it. So then I put it into operation. So over here is the system design, and over here is the actual operation or performance of the system. So final thoughts. SMS doesn't need to be extensive, expensive, or sophisticated. Keep it simple. It needs to be a tool that helps your organization. One size does not fit all. SMS isn't a manual that you stick on the shelf or an annual audit. SMS is an integral part of your organization. It's interwoven into your documentation, your processes, your training, your culture. And SMS is all about how well decisions are made. The key is to build trust in the organization among your employees. Have them tell you what is going on, communicate, so that you can gain knowledge and make better decisions. Thank you.
This morning, Damon talked to us a little bit about the basic principles, basic elements, and the pillars that all safety management systems are based or built from. And now we're going to start going into the realm of how are they different in the various industries? How do they go about implementing the policies, the cultures, the SRMs, the safety assurances in the different industrial practices? We'll have, first of all, an overview that compares various principles across these industries by Richard Steckel. He's currently a senior researcher here at the Center for Aviation Safety Research and Parks College of Engineering, Aviation, and Technology. His research interests include safety management system implementation, aircraft accident prevention, and unmanned aircraft systems. Richard is employed for 24 years at Boeing here in St. Louis in quality assurance, where he supported aircraft manufacturing operations. He's also an American Society for Quality certified quality engineer and a certified quality auditor. He received his BS in Aero Operations from San Jose State University, his MS in Aviation Safety from the University of Central Missouri, and currently completing his PhD in Aviation here at Park St. Louis University. Let's welcome Richard Steckel.
So first, a short history of aviation safety, where we've been. This is one of my favorite quotes. I call this the Darwinian era of aviation safety, where it was survival of the fittest. So from 1903 to 1925, it was basically unregulated. Aviation was sort of a free-for-all. And I was thinking about that, and before 1903, the philosophy was crash, fix, crash. And then in 1903, when we finally started flying airplanes, we finally moved to fly, crash, fix, and fly. So up until 1926, we had no government regulation of aviation. If you could design it, or think of it, or thought it might fly, you could build it and give it a whirl. So in 1926, the government said, you know, we need to protect people from airplanes falling out of skies and people killing themselves. So they legislated the Civil Aeronautics Administration to regulate pilots' licenses. Now pilots needed to have a license to fly, flight schools needed to have a license, mechanics needed to have a license. And it's interesting, just as a point of trivia for Parks College, in 1927, we became the first certified flight school in the United States. So we still have certificate number 1 as a flight school with the FAA. So they started regulating flight schools, pilots, mechanics. They appointed an administrator to carry out the policies, and then even created an accident board. So at this point, they decided we need to start looking at those accidents, see if we can prevent them from occurring again. So even though it was reactive, it was a start. From the period 1926 to 1974, most of the improvements were based on technology or learning from our mistakes. And a couple of major ones here, medicine has recently adopted checklists, and they use aviation as the model. We didn't start using checklists till 1937, and that was brought about by a crash of a B-17 that was being test flown, and they finally realized with the more complex airplanes, that at that time that was the most complex airplane flying, they realized you couldn't hop into an airplane like you can your car and start driving or start flying. So that's when checklists were implemented due to that accident. Positive control airspace and the FAA providing more oversight as far as travel took a collision of two fully loaded aircraft over the Grand Canyon to finally bring about positive control airspace. So we learned from our mistakes too. And with that, in the early 60s, with the accident, not knowing what happened in the cockpit, not knowing what the plane was doing, that brought about cockpit voice recorders and flight data recorders. So now we can find out what happened during the flight. Finally, we get to 1974 to 95. We're starting to get some isolated cases of proactive safety. And a classic example here is one in 1974 where a TWA aircraft crashed into the side of a hill flying into Washington, D.C. because they misinterpreted a chart that gave them directions for landing. Turned out, after some investigation, it turned out United Airlines had discovered the problem before TWA. They had an airplane almost hit that same hill. They got communication out throughout the airline, let all their pilots know, made sure they were aware of the risk, but they never got it outside the airline. So they weren't able to give that information to other people. So with that accident, that brought about the NASA Aviation Safety Reporting System, which is a national database. Any pilot, mechanic, operator can put in a hazard report or an incident report that's de-identified, non-punitive, and gets that information to other people. Finally, in 1995, they started looking at this and said, we need to do something proactive. They had an FAA Safety Summit meeting in 1995 in Washington, D.C., where they said, we need to do more. You know, we've done some already with the ASRS. We're bringing in flight data recorders. We need to do something preventive. With that meeting, that brought about a lot of the things you see now in aviation with aviation safety action programs, flight operations quality assurance programs, where we actually monitor flight data recorders when nothing happens. We'll pull those and look at the flights to see what's going on a normal flight. We'll look at cockpit voice recorders to see what's going on, not just when an accident happens. So all these were brought about with that. Line operation safety audits, which is something I'm doing right now with our school at Parks, where I'm actually putting cameras, flight data recorders, and microphones in 2 of our aircraft and seeing what goes on in a normal flight. So industry comparisons. So we've seen what aviation has done. We're finally getting where we're proactive. We have these programs. We're looking at SMS. The FAA is looking at implementing SMS, making it mandatory in the aviation industry. And so how do we do that? What can we do to compare? What are other people doing? So why do we want to compare with other industries? Well, what's out there now? What are other people doing? And that's part of the purpose of this conference today is, can we exchange ideas and get best practices? You know, what can we learn from other sources? How can we use them for our own system? And what will we need to create that we don't have that somebody else may have? So one of the first ones I looked at, I did this for the FAA, we looked at comparing safety management systems to our current regulations. Because the industry right now, the aviation industry is looking at SMS and saying, well, why do I need this? I have regulations. I should be safe enough. So we did a comparison. We looked at what SMS wants to do versus what regulations do now. And this is a quote from someone who does a lot of aviation safety consulting, and this is a reaction he gets. Many companies claim they have an SMS by the virtue of the fact that they have a flight operations manual, follow the regulations, and provide training and do all the rest of that. So what is with regulations? It provides minimum compliance for safety. Doesn't address specific issues. So if I bring down weather minimums for a certain airline or a certain operation, that may not take into consideration an airline that's operating in Alaska and a lot of bad weather, or somebody flying in the Caribbean where there's no weather. So it's drastically different operations. And regulations are black and white. They say this is what you must have. If you don't have that, you don't qualify. So like the gentleman brought up about the 1,500 hours, you know, there's something apparently magical about 1,500 hours with a pilot. At 1499, he's not qualified. All of a sudden, at 1501, he is. So as an example, I use speed limits. Driving, you know, you can go out here to Interstate 70 on the way to Kansas City, and the speed limit's 70 miles an hour. That's great on a sunny day, no weather. What if we get fog? What if it's night? What if we have snow? Is that 70-mile-an-hour limit still valid? According to the sign, it says you can still do that. Aviation, we have weather minimums. Construction, you have building codes. And usually those are the minimum required. And they say, you know, well, I've got regulations. Well, this is an example of where regulations didn't save an airplane. This is the infamous Colgan air crash in New York back in 2009. And this was the findings from the NTSB. The flight crew was properly certificated and qualified to fly the airplane. They were legal. The aircraft was properly certified, equipped, and maintained prior to the accident. So if we look at that, the flight was legal. It met all the legal requirements of the federal aviation regulations. But was it safe? So then we start looking at the probable cause. And you can see by this response here, the crew, it turned out to be human error. Some of the things we're looking at is safety management. You know, what's the risk of human error? Some of the other findings, pilot's performance was impaired, fatigue, again, human error, or a system problem. And the airline didn't proactively address safety with commuter-based pilots commuting. So safety management or risk management wasn't adequately done in this case. And even the NTSB said the operator has a duty to identify the risks and mitigate these risks. So aviation versus quality management, let's look at that. You know, people say, well, we've got a QMS system. I worked at ISO 9000 or some other quality standard. We looked at this at aviation too, because again, the aviation operators are saying, why do I need safety management when I've got, say, a quality management system? Now the FAA has actually based their SMS system off QMS, and they even say so here. And they define the difference between quality management and safety management is SMS is what we do, QMS is how we do it. And they admit that QMS has already established a lot of the principles for SMS, so they are very, very compatible. So if your company is using a QMS, in many cases you can take the majority of that and bring that into your safety management system. You don't have to reinvent the wheel. So the main difference Main difference between QMS and SMS is identifying defects in QMS and identifying hazards in SMS, as Damon talked about in this previous presentation about, one of the main roots of SMS is hazard identification and risk management. And this is from an aviation service provider. Here's again from the same TIMCO Aviation Services. So they say QMS satisfies most of the requirements and begins setting up an SMS. So if you have a QMS, you're on your way. So then we also looked at, for the FAA, they were asking, we have our SMS system, what are some of the other industries doing? So I, again, stuck with transportation, since that's an area I'm a little more familiar with, and the panel after me is going to discuss some of the other industries. So we looked at rail and maritime. It was very interesting. So what are the differences? What are the similarities? What can aviation learn from other industries? So what I did was took the Commuter Rail Safety Management Plan, looked at that, compared it side by side with the SMS model from the FAA. This is what I came up with. It's very interesting. Very close to FAA, except they didn't really discuss management review and safety promotion. That seemed to be a little weak in their area. But they did have the other three pillars that Damon discussed very well covered. And what was really interesting was went above and beyond the FAA SMS standard in talking about the environment. So they actually talked environmental management, safety contract requirements, so when they, and below here, contractor safety coordination. So when they have a contractor come in, that person has to adopt their safety management system or get some training or comply or work to their system. It's just not someone comes in, does the work and leaves. He also has to comply with and mesh with their safety system. The other thing that Rail also stressed was looking out after their passengers and people they don't even deal with. So they looked at rail crossing station platforms where they might impact other people. They looked at workplace safety programs, employee safety programs, and I think on the next one here I've actually got, they actually make fatigue a part of their safety management system. They address that within their safety management system manual, as well as these others. So they look at the operator almost more than the FAA does with pilots right now. Maritime. I looked at the International Management Code for Safe Operation of Ships, also known as the International Safety Management Code. And again, some interesting findings there. It was interesting comparing the two. Again, maritime's very similar, met most of the requirements. Areas lacking that I saw was continuous improvement and really only addressed corrective action. They were more reactive than proactive. They had some proactive in there, but they really looked at addressing problems that occurred. And they also didn't really go into looking at a system description and task analysis, really looking at the SRM side of the SMS model. But the Maritime did go above and beyond the FAA. They did have an environmental policy, which the FAA SMS does not have. They also have certification and verification. So when you get your SMS certification from the ISM, it's only good for 5 years. And it's only good as long as you do an annual audit within yourself, do an internal audit. So they actually have performance standards once you get the SMS certification. And probably the most interesting one was it'll be made available and accessible in all working languages. And when you think about that, especially the maritime industry, you're looking at ships that are registered in various countries with crews of various ethnic origins and country origins. So that's absolutely critical if you want to get that information down to all of your employees, that they have that accessible in all languages. And it's one thing that probably aviation is not looked at specifically, because technically English is the international language of aviation. But as Damon was talking about our trip to India, I went with them also. We did some consulting with an airline over there looking at their safety management system. You know, English was probably going to work. That's one of the languages of India. You know, again, most of the flight crew, flight attendants, mechanics speak English, but all their baggage handlers did not. And so we saw a need for their safety management system to include, we need to make sure everybody can understand this and read it. So something to think about, especially if you're an international company. Lastly, emerging trends. Something I did find, ISO 22000, the Food Safety Management Manual, has recently come out, and they've done something really interesting. They've actually combined safety and quality into one document. So it's actually an SQMS. I think that's something you're going to see more of in other industries, a safety quality management system. In fact, we've discovered a couple of aviation organizations within the United States that have taken on their own effort to create their own SQMS. There's no industry standard right now for that. It's being done at the individual organizational level, but I would think in the next 5 to 10 years we should see something like this within the aviation industry and hopefully across all organizations. So, conclusions. I'm going to end up here a little extra time. Evolution of aviation safety was a slow process. We did not invent it overnight. It's taken us a long time to get where we are now. And we're still progressing with SMS. That's something new for aviation. We're just starting to implement that now within the industry. Being legal does not always equate to being safe. Quality standards have many common elements with QMS. I think the two are very compatible. In fact, I've talked with other quality professionals now. I've come into the safety arena, and in many cases we talk back and forth and say all we have to do between quality and safety is just transpose the words, put them in the other standard, and you almost have the same thing. So safety and quality are almost interchangeable. We're both trying to prevent defects. We're trying to prevent from hurting someone. And finally, you can leverage, if you have QMS, you can leverage that for your SMS. Any systems you have in place now, it doesn't even have to be a QMS. As Damon talked about, whatever you have now, even if it's informal, you can bring that into the SMS. I'll end with one story on SMS implementation in the aviation industry. I have a friend who's a corporate pilot, and they went out to get ISBAO certified, which is International Standard of Business Aircraft Organizations. Came in, they did the audit, they were looking at what they had, and they had just a really simple file Rolodex system. And whenever they went to an airport, if they saw a hazard or a risk, they'd write it down on the 3x5 card, bring it back to their operations, put it in the Rolodex. The next pilot going out to that destination would go through the Rolodex, see what was going on, see what the hazards were, note those, and then go fly. Well, after the Lexington, Kentucky Bluegrass accident where the Comair flight took off on the wrong runway because it was very confusing, he went back to his system, the simple Rolodex, went through, looked up Lexington, and one of their pilots a year and a half before had written down on a 3x5 card, when you're taxiing out for takeoff at night, be careful because you could take off on the wrong runway. So they had identified that hazard over a year before that accident occurred. And so when they got certified, they had this card system. They showed it to the ISBAO auditor. He said, you know, if that works for you and it's effective, continue doing that. Don't reinvent the wheel. So there's ways you can bring in things from other industries, things you're already doing to make your own effective SMS system. Thank you very much.